Good afternoon. Yeah, it's me again. Sorry about that. So we are now having successfully eradicated a gremlin from the system. I now have the pleasure of turning you over to Jason, who's will be giving us a very exciting talk about revolutionising biodiversity monitoring, which obviously involves puffins.
Something to do with puffins.
Excellent. Jason.
Okay, so everybody's been out and had a little bit of a drink, but I think we're going to try and energise everybody a little bit more so you can really engage with the presentation. So those who can everyone please stand up out of their chairs? We're going to do what's called the stretch and breathe. It's really simple. It's not yoga. Anyone can do it. I can do it. So the first thing I want everyone to do is stand with their feet apart quite comfortably and raise your hands up. All the way up, palms flat, as if you're going to try and stretch up and touch the ceiling. Big stretch. Everyone that can. It feels having a go. We're all doing it, right? Real big stretch. And then bring your arms down to here. Shoulder height. And then as if you're trying to stretch the room. Stretch the room. That's it. Nice big stretch. Okay, and now arms back down and relax. Okay, we're going to do 3 nice big deep breaths. Okay, ready? So the first one, big deep breath. Hold it for a little bit. Let it out. Number 2, big deep breath. Let it out. Last one, big deep breath. Let it out. Now you can all sit down and I'm going home. Right? Well, thanks everyone. Thanks for attending the AGM, and more so, thanks for staying to capture some of what I'm going to talk about today. Capture being the kind of capitalised, underlined words here. Before we start, does anyone know, or has anyone ever heard of Species AI capture before? Show of hands. Good. Good, because that means it's a really good niche that I'm going to make a lot of money in. Okay, let me find my clicker. Okay, so what is species AI capture? That's the first kind of big question. So species AI capture can be simply defined as the use of using machine learning technologies to automatically detect, identify and record lots of different information about various species in their natural habitat. Okay, why is ecosystem monitoring important? So biodiversity and ecosystem monitoring is absolutely essential for understanding the health and stability of our environment. We monitor like a whole diverse range of life forms in a given area, which helps us to recognise changes over time, whether they're natural variations or caused by human activities. Traditionally, monitoring wildlife there were a whole lot of what I would call very manual techniques. Things like direct observations, so actually you're there with your binoculars looking at birds, collecting soil samples, picking up small insects, etc. A lot of clipboard recording, a lot of paperwork, taking photographs, trapping animals to monitor their behaviour, then obviously releasing them, tagging animals to look at population behaviour and what different species are doing. And of course, audio monitoring, being out there with your tape recorder and your microphone and recording animal sounds and songs. So a lot of very manual, kind of tedious work. Of course, that kind of manual monitoring, there are some kind of pitfalls from that. And one of those is the fact that it's very open to human error. It's easy to miscount things, lose paperwork, forget to write things down. And also, some of the people that are recording this sort of information have kind of a bit of bias sometimes on what they're recording, especially if they have some emotional connection. A lot of people that do this are probably ornithologists or have an interest in nature. So there's definitely room there for there to kind of be a bit of bias. So what we're looking at with species AI capture is monitoring wildlife, monitoring ecosystems and biodiversity digitally. We use things like automatic image recognition to identify species and count population, sound identification, we can positively identify sound, and all this has been made possible with AI and machine learning. We're able to analyse noise, we look at noise levels in different habitats to see whether human beings or any other kind of outside influence is causing issues. We can put out a whole variety of different kinds of sensors. Everyone knows IoT, the Internet of Things, where you have so many different sensors that can be connected up Bluetooth and Wi-Fi. We can monitor things like moisture, temperature, air, pH levels, water quality. All these things are important, not just monitoring the wildlife themselves, but monitoring the natural habitat and the natural environment around them. And then from that information, we can do a lot of quite interesting predictive modelling and simulation, which helps to make really important decisions when thinking about conservation. And of course, we're collecting all that data in a non-invasive way, and it's all being collected accurately and being logged. Of course, it opens up big questions about the data. Obviously, there's someone coming from Microsoft tomorrow talking about cybersecurity. You have to be quite careful with how you store the data, how you transfer the data, how that data's kept and collected. Okay, so how did I get into species AI capture? Cut a really long story short, about 4 years ago, I met a team of very passionate, like-minded AV professionals running a small company who wanted to try and survive over lockdown. A lot of companies were folding because the work wasn't around, and they asked me if I could go and have a look around and try and find some interesting little niches we could work in that wouldn't necessarily be affected by lockdown. That's a really hard thing to do, right? Anyway, through a distributor, I got this crazy phone call one day saying, Jason, I've got this customer who wants to put some cameras on an island in the middle of the North Sea to monitor puffins. He said, I've spoken to all the other AV installers I know and nobody wants to touch it. And then I thought of you. And I said, thank you very much, Kenton, thank you very much for that. I just dropped a name in there. I don't know who of you know Kenton. I said, thanks, Kenton. I said, but really, he said, you know you want to do it, Jason. Hence this project almost fell into our laps. And we've been working with the customer, Southern and Scottish Electric, ever since. The first video I'm going to show you is basically a video that the BBC made. It was one of the BBC Click episodes. It's about a 5-minute video, but it explains basically what the project was about and what we were doing on the Isle of May. So hopefully, when I press this, it should start up.
So we talked about how putting up wind turbines might affect the local wildlife. Well, Nick Queck has been out into the North Sea to find out how one energy company is trying to prevent problems for a population of puffins.
Nine miles off the coast of Wick, at the far north of Scotland, it's wavy and it's windy.
You can see them there on the horizon.
I've come to visit the 84 turbines that make up SSE Renewables' Beatrice site.
This is one of the UK's largest offshore wind farms, with enough capacity to power almost 500,000 homes.
The UK government, though, wants enough wind energy to be generated to power all of British homes by 2030. And it's cut approval times for new offshore farms from 4 years to just 1.
Of course, it's not as simple as just sticking these things into the seabed.
Right now with offshore wind and the scale of development that we're going to see, we just don't yet know how that's going to impact the oceans. So we always need to think about what's the impact on habitats and wildlife, and especially when we're harnessing nature's resources, then we need to make sure that we're protecting the natural environment too.
There's loads of them.
They've been conducting a study with Microsoft and Avanade on the Isle of May in Fife, home to fauna such as seals, ducklings and the much-loved puffin.
This is a sanctuary for puffins, with around 80,000 nesting here each year.
It's estimated because traditional counting has been done by eye, so researchers have engineered a way to keep better tabs on them.
The effects that we see from building offshore wind farms isn't seen immediately within the local ecology. It's obviously an effect that takes time, and what's really important is that we start monitoring the local ecology to our wind farms so that we understand the impacts we have, so that we can implement corrective actions and potentially have a positive impact.
They've installed 4 artificially intelligent camera systems to count puffins and monitor their flight, each equipped with their own custom-made marine-grade jackets.
You can't buy this off the shelf.
Right, okay.
And we've had these created specifically for these 4 cameras which are on this island.
Right. And so the puffins are under CCTV surveillance?
They are, 24 hours a day.
Are they happy with that? Is that a wee windscreen wiper?
That is indeed, yes. And that allows us to perform periodic maintenance, ensuring that we can clean the lens of any salty deposits which picked up from the harsh sea air. Puffins generally, when they're congregating around their burrows, tend to face out looking down this hill. So we have one camera position further down the hill looking straight onto the puffin, giving a good view of the portrait, whereas this gives a good side-on view of the profile of the puffin.
You're quite right, I can see one right there actually.
Exactly,
looking
yes.
side on.
So as part of the trial, we really wanted to understand what would give the AI the best opportunity to recognise a puffin. In February, this was just a barren ground. There was no grass, let alone flowers. And you can see here now all these white flowers that have bloomed. So the white flowers actually merge with the breast of the puffins in terms of the pixels for the AI to pick up. So it was actually tricking the AI.
Oh, right, okay.
Yeah, and actually resulted in slight inaccuracies until we retrained the model to identify the puffins in amongst the white flowers.
Wow. So actually ended up not being as simple as you thought it was going to be.
No, it certainly was not, but that was the reason for the trial. We wanted to explore, understand what works well, what doesn't work well, and yeah, there's many takeaways, one of them including seasonal training of the model.
This is chiefly a data gathering exercise, the initial entries for a long-term puffin digital database.
Already we're building up quite a strong picture of how the puffins behave during certain times of day, understanding when there's peak puffin activity versus low puffin activity. So very soon we should start to be able to understand when there's any anomalies in this behaviour. But at the moment it is still very early and we are still trying to understand the data and really start pulling it together.
We've got a very narrow window of time in order to ensure that we can protect a lot of ecosystems that are in huge danger, and so it's something that's incredibly close to Microsoft's heart.
Is there a bit of responsibility or a bit of maybe even guilt sometimes when it comes to addressing the climate change issues surrounding technology companies having such a carbon footprint?
Well, we know that the carbon emissions that Microsoft have, it represents less than 1% of the global carbon emissions. But you're right, the data center footprint is one that we're really focused on. And I think in the world that we live today, the demand for data and technology is one that's growing.
And to satisfy that demand, we'll need more electricity.
The thing is, if we're to reach government targets and lessen our dependence on burning fossil fuels, then we're going to have to embrace renewable energy.
Let's just hope the rollout is a harmonious one for everyone's sake.
That project was an absolutely fantastic success. It took us about 6 months to plan it. We're only a small company at Excite. We've got 12 employees. In fact, we only had, I think, 9 employees then. So we put together a project team of subcontractors. We had subcontractors for the cameras, for the mechanical engineering, the electrical engineering, the IT engineering, the RF that we had to put on there because the 4G signal on the Isle of May was just not very good at all. So we brought a satellite company in to put satellite equipment in. And my two fellow directors, Alex and Gareth, were still nervous that we weren't going to pull this off. But it was an absolutely fantastic project. Everyone worked really hard. We kind of patting ourselves on our backs. From that, it opened up the door to a huge amount more projects, a lot of varied projects, which you're going to hear about soon, looking at all kinds of other different kinds of wildlife in lots of different types of habitats. But there were challenges, especially working in a marine environment. Now, years ago, I spent a lot of time working on the cruise ships and the ferries, so I'd had a little bit of experience of what salt air can do to equipment. In fact, I remember one day being on the top deck of a cruise ship, and one of the officers saying to me that the speaker wasn't working, getting up on a ladder, a little A-frame ladder, taking the speaker off, opening the back, and emptying the speaker out of the back of the cabinet in it, which had fallen into its component parts. So we all know that a loudspeaker uses lots of different types of glues, adhesives, screws, etc. And the whole speaker had just fallen apart into its pieces, as if you were buying a recone kit to kind of put the speaker back together. So salt air is awful. It just fails adhesives, it corrodes metal. Really, only stainless steel and only a certain type of stainless steel will put up with it. Everything else just corrodes, and it doesn't matter what you do and how well you seal things in, the salt air still gets in and starts to corrode things. I remember even inside the cruise ships, some of the tills, even like inside the ship, some of the DJ equipment, PA amplifiers, everything just corroding away, and that stuff's not even outside. The salt air's just getting in through the heating and ventilation system. Some other challenges. Have I gone the wrong way? I have. No, that was the right way.
Oh, sweet.
Sorry. Okay, yeah, we're going to have a look at this one first. Before we get into like some of the real challenges that we had when we were doing the marine engineering, that project at the Isle of May led us on to our first actual install. So the Isle of May really was kind of the proof of concept to see if things would work. And then SSE were so impressed and excited to move forward, they gave us our first install project. This was right up in the Highlands, a place called Dunbeef, not very far from, right from the top of Scotland, absolutely in the middle of nowhere. They said, we want 4 cameras here to look at this rock out at sea. You're going to be putting your camera right on the edge of the cliff. This is just a short video, but basically shows you this was our kind of next kind of big install.
First, in terms of how we're applying this technology. So the project here at Dunbeef is to install a camera system for monitoring the puffin colony local to the Beatrice offshore wind farm. Previously, the counting puffins was a very manual task. So you can imagine going out to the field with a clipboard, they maybe take some photos, they have binoculars, and these activities can only take place, once or twice a year. Having a system such as this gives us monitoring for 16 hours a day, every day of the breeding season. We have 4 cameras here monitoring the puffin stack from 4 different points, and the video footage is then streamed up into the cloud, where it's processed by our AI model, which aggregates the counts from the 4 cameras to give us an overall colony count. This is a world's first in terms of how we're applying this technology. So Microsoft have used similar technology in the past for sort of one-off projects, but in terms of actual environmental monitoring, this is a world's first. The data that we're collecting from the AI model is then shared with NatureScot as part of our consent conditions for the Beatrice offshore wind farm. There are discussions around us potentially sharing this data publicly and making it available maybe via our website. We could have live streams of the cameras with the AI overlay on top and also have some statistics available. But at the moment, this data is going to be used for regulatory compliance with NatureScot.
Okay, so let's have a look at some of these. Some of these were quite big challenges, actually. Certainly at Dunbeef, one of our biggest challenges was actually getting the equipment to site, because there wasn't a convenient road and then like a little path down to where you were going to put the kit. It was just fields, and a lot of it was muddy, slippery, long grass. Some of it was slopes all the way down to the edge of the cliff. You know, no fence there. You know, how are we going to get equipment just across there? Where are we going to put all our equipment? Where are we going to put all our staff? It was a massive team on this Dunbeef project. One of the reasons for that is number 2 on my list was power distribution. There aren't any conveniently placed double sockets on the side of the cliff. Where are you going to get power? You need power to power the cameras, the computer that's doing the recording. We've got a local NAS drive in there that's backing up all the footage. And then, of course, our 4G modem to actually get the video files up and out to the cloud so that they can be processed. So what we managed to do, we managed to find a friendly farmer. And the farmer said, yeah, you can absolutely use the sockets in my barn, but I'm going to charge you for renting my land. And he said, by the way, I've done a quick measurement on the drawing. I've spoken to my land agent, and the barn's about 500 metres away from where you're going to put your sockets. So he says it's going to be a long extension lead. I was like, well, you can't just use a long extension lead. You know, over that distance, there's a lot of calculations you've got to do about, obviously, voltage drop. So you can't just get your 500 metre reel of cable out. You've got to put in a big, fat piece of heavy cable. In fact, £15,000 worth of steel wire armoured cable. And you've got to drag that through a field. You can't just lay that on the ground. You've got to dig a trench, and if you've got to dig a trench, you've got to have a JCB. And if you've got a JCB, then you've got to have another truck to pick up all the soil so the soil can go back in again. And by the way, you can't just have a couple of people on the end of the cable pulling a cable. You've got to tow that cable along with something. You know, it's a heavy piece of cable. So, of course, I'm loving this because the numbers are going up and up and up and up, right? Because we've got to do all this, you know, do all this work. Something else, obviously, that you have to think about when you're putting electronics in a coastal situation or marine situation is how you're going to protect the electronics. I was talking to Peter about this earlier. It's a real big problem, but salt air just gets into everything. In fact, the system that you've just seen at Dunbeef, we've put what I call a telecoms cabinet up, you know, the big green cabinets that you see on the side of the road. It's got all seals around the door. We put a fan on the side with a filter on it. It's still not filtering all the salt air out. There's still salt air getting in, and we can just about now see USB cables that are starting to rust around the edges of network sockets. You know, we're going to have to go back and do some periodic maintenance on that. In fact, SSE still haven't set up their support contracts, which we're supposed to be getting in a week or so's time. So yeah, protecting electronics, that's a really important one. Obviously, staff welfare. Again, we're out in the middle of nowhere. The only place I could find that possibly could have helped was there's a tiny little Croft museum, probably about 200 metres away from the site, and they had a little cafe there, and I was like, great, we'll rent the cafe. We'll just rent the cafe. We'll pay them for the cafe. We've got food, drink, somewhere warm for the crew to, you know, take off their muddy stuff, blah, blah, blah. Somewhere to put a laptop, have a little bit of a site office. No, sorry, we can't help, it's closed, we haven't got enough staff to run it. I said, well, can't we just borrow it? No, sorry. So in the end, we got their car park and we turned their car park into a builder's compound, right? We dropped a welfare unit down there, we put storage containers to put all the kit in. We had like a little production village for a couple of weeks. It took us a week to basically dig the trench and run the cables in before we could even start putting all the electronics in, building a massive great concrete plinth, and putting up a marine architect design camera mast because the winds were so high there, we didn't want anything getting blown off the edge of the cliff and into the sea. So, got some pictures there. So we hired a couple of these all-terrain vehicles, and we also had to hire drivers because we weren't insured to drive these things. And these things look like a car, but they're really not that easy to drive. So we had those. We had a couple of tractors as well. obviously a JCB and a JCB handler, and then somebody to basically drive a dumper truck for the soil. You can see this is the 500 metre cable route. Obviously, there's our camera. I'm shaking, and then up here is is basically the barn position, and we looked at lots of different routes and ways we could get through. Because across here, where that little blue dot is there's a water course which we had to run a cable through. Of course, anything that's kind of like protected by Nature Scott or whatever, or is heritage or is a conservation area, then you almost have to get on your hands and knees and plead to be allowed to just dig a little tiny trench. You can see there the trench being dug. I mean, I love the picture on the right because it just looks like it goes on for miles. And honestly, it looks like an easy task, but it really isn't. It's extremely labour intensive, that job, but definitely a challenge. I think, I've been in audio visual for nearly 35 years now. I've been in pretty much all areas of AV, but these are the jobs that I guess really kind of float my boat, that get me excited, because they're just out of the box projects. And they really are adventures, they really are challenges, and you feel really quite satisfied after you've completed one and the customer's happy, and then you get paid. So you can see here just a couple of pictures of you can see how close we had to put this cabinet to the edge of the cliff, and the huge grate. I wanted to take some pictures of it and post it out as the monolith, the big concrete block there that we had to put down to bolt everything to. But I mean, we've over-engineered everything there. The cabinet, you can see how thick the poles are for the mast. All of that is marine grade, and then it's all been coated with a marine grade paint as well. And this kind of British racing green colour's become our kind of trademark now. So for all the kind of environmental jobs we do, we're using this green colour. And there you can see us basically dumping down the welfare unit. I don't know how many of you have used these welfare units before. They're incredible. It's just like a 20-foot shipping container. One end's got a diesel generator in it and a couple of big water tanks. And then you get inside and you've got pretty much everything you need. You've got a toilet in there. You've got like canteen-style tables. You've got a sink, power sockets, lights. You could be completely in the middle of nowhere and you've got all those, conveniences around. And then we hired a couple of 10-foot containers as well, just to put materials and equipment so we could offload things out of the vans. And obviously, I guess kind of reduce the carbon footprint a bit, because rather than having to bring all the vehicles to work every day, everything could be just offloaded in the containers and all the staff could come in one vehicle. So that was quite helpful. And I think the biggest thing for me about a lot of these projects was, yes, the technology and the science is really interesting, and I had a lot of fun designing and building these video capture systems and working out how we were going to transfer massive amounts of data over the 4G network, because it's all right if you've just got sensors and things that are recording sound or temperature, you're only talking about small amounts of data. But they wanted 30 frames a second at 1080p. Video is the largest, biggest data you can send. But from this, because we were doing so much with 4G modem, sending stuff across the 4G network, pretty much everywhere we worked, we did 4G. Only a couple of places where we had to use a satellite connection. We were able to sell the client the data as well. So we've become basically an ISP, an internet service provider, and we're now selling the client the data and the SIM cards. Of course, that's your automatic money because it's the gift that keeps on giving. So yeah, really, really interesting. But I think besides all of the technology, for me, I think definitely the exciting bit for me is just building the teams and the camaraderie that goes with it, the camaraderie, the friendships that you make, the relationships that you build with your team members. I would say we've got probably one of the best teams together that I've ever worked with, and everyone is, absolute specialists in their in what they do. So if you look at this picture on the right, so we've got Gavin here, he's from a company called Resco, he does all our 4G comms and satellite. Richard's Excite Electrical, Ben's our chief electrician for Excite Electrical. Then you've got Katie and James. Katie's actually an aluminium welder, and she built all of the camera masts from scratch, welded all the camera masts, designed and built them herself from a company down in down in Southampton. Then you've got Shane there on the end. Shane's just a small manufacturer that builds marine grade illuminators, whether they're like LED or infrared. We try and build a lot of bespoke equipment because it kind of fits the application and we know it's going to work and it's going to stand the test of time and withstand like the really harsh and kind of rigorous weather conditions. So we've seen a couple of our projects. So Isle of May was the first one. Then we moved to Dunbeef to look at the puffins. From that, we started looking at using technology in other places. One of those is at hydro stations. There's so much here, I had to kind of cut everything down. But we're now doing 18 hydro stations for Southern Scottish Electric, where we're using cameras to count the migratory Atlantic salmon as they swim through the fish passes. 2 of them are underwater cameras where the fish swim through the fish ladders. I don't know if anyone's ever been to Pitlochry, seen the fish ladders there. And then the rest of them are what are called born and lifts. So the fish swim in at the bottom of the dam into a vertical chamber. The chamber fills up with water, gates close on a time switch. The chamber fills up with water, and then the fishes are let out at the dam level to swim across. But as they let out at the dam level, we've got a camera there that counts them as they're passing into the river. And then from the salmon, we started looking at what we could do in very deep water. This is the bit that's really getting me excited at the moment. Is the prospect of doing some offshore sensing, and you'll see some of that, some of what we've achieved in a minute. So Southern Scottish Electric, as with a lot of other energy suppliers, obviously have a corporate and social responsibility. And part of their corporate responsibility obviously applies to the environment around their power stations. A lot of these projects are basically putting ticks in boxes to enable them to get their operator's licence. So the last couple of projects were all around Berwick Bank, which is this ginormous offshore wind farm. But in order to get the offshore wind farm, you know, the licence to run it, you have to satisfy all of these environmental conditions. And some of those are all based around conservation. So if it wasn't for what we were doing, they wouldn't be able to tick those boxes and they probably wouldn't get their licence to run. So this stuff is really, really quite important to them. So there's a lot you can do kind of in the periphery, like with the seabirds, etc., monitoring the seabird population, seeing if that changes. But another thing is called offsetting. So basically for all the birds that get chopped up in the turbines of the wind farms, because it does happen, what could they do to kind of bring nature back? And one of the things that they're looking at is using what are called these artificial reefs. So they're these big concrete, they're called Apollo reefs. So remember the Apollo space missions, the Apollo capsule on top of the rocket. The reef looks like an Apollo capsule. It's a big concrete, almost like a bell shape unit with holes cut in all around and a cage inside. And they drop these down onto the seabed around the rotors. And basically the idea is to encourage fish and other sea life to come and create habitats. And one of the things that we're being asked to do is look at ways that we can put sensors on these reefs to see what habitats are starting to build in there. But that's offshore in very deep water, trying to work out how we're going to get cameras down there, illumination, or do we not use cameras at all? Do we use some other kind of sensing equipment? Do we use LiDAR? You know, do we laser scanning underwater? Do we use sonar? There's some very, very clever sonar equipment available. You'll see some of it in a minute. So that's another project we're looking at, is going now from the kind of fresh water out into the salt water and actually underwater. And then just recently we did a project for another branch of SSE for their thermal sector, which was a power station in Ireland. It's always a pleasure to work in Ireland, especially if you like Guinness, because you can't drink Guinness anywhere else once you've been to Ireland, right? And the people there are so friendly. We always try and integrate with the communities and around the places we're working, because it's helpful to us. You know, it's good PR. We're making friends all the time. So this particular power station, they use salt water. It's a thermal power station that uses gas to create electric. So when they haven't got enough electricity, they can turn on the gas, heat up some water, turn it into steam, create some electric. And the problem they had is where they're using seawater coming into the power station, they're using seawater and then it's exiting out the other side. The water is moving so fast that it creates foam on the water, a bit like bubble bath type foam. But this stuff is horrible. It's really scummy, smells bad, it's got a horrible colour. And of course, bits of it were turning up on the beaches. So local residents were starting to complain. And they said, well, what are you doing about this? And, well, we've got a guy with a clipboard that comes out occasionally and uses a pair of binoculars to see where bits might float. And they're like, well, that isn't enough. You've got to do something more. So they called us up and said, look, off the back of what you're doing with the wildlife cameras, can you build us a camera system that will monitor the foam? I said, well, during the day, it's not a problem. They said, no, we want it 24 hours. I'm like, well, how much foam do you want to monitor? Oh, about 600 metres out into the bay. Right, okay, going to need some lighting. So along with Shane, who you can see right on the left-hand side of the picture there with the shirt on, the top right-hand corner picture, we built these massive infrared lights, infrared radiators, again, which had to be marine grey because they were on the side of the sea. But that lights up to 600 metres out into the bay like a football pitch. Absolutely amazing, amazing. So, and these projects just keep on coming, and they're definitely a big part of our kind of annual revenue now. But yeah, I just wanted to finish off with one last video which kind of sums it all up and also shows you some of the really exciting kind of cutting edge technologies that we're using for underwater. This is, for me, this is the biggest draw, and I hope this year that we're going to start to get a bit more involved in some of the offshore projects.
In March 2020, SSE Renewables Digital Ventures team partnered with Microsoft, Avanade and NatureScot to form the Flying Squad. The goal was to develop an innovative approach to environmental monitoring to achieve compliance with the consent conditions for the Beatrice offshore wind farm. In May 2020, a 6-week proof of concept project was completed, with the Flying Squad developing an AI model that could accurately identify and count adult puffins. The model was developed as a desktop exercise using freely available video and images of puffins from the internet. The proof of concept was a great success, and the team from NatureScot agreed that the next step would be to perform a live trial on the Isle of May, which is home to 80,000 puffins during the breeding season. A new development in the model for the live trial was the introduction of the green centroid tracker that is assigned on recognition and allows a puffin to be tracked for 10 frames if no longer recognised. This supports improved accuracy and reduces the potential for double counting. The model achieved an average accuracy of 85% and was deemed a huge success by NatureScot. Further retraining of the model, using footage from summer months on the island, would only further increase this accuracy, expected to be around 95%, seen in more recent species AI projects. In December 2021, the Moray Firth Regional Advisory Group approved our application to monitor the Dunbeath puffin colony using our AI technology. Installation for live use in Dunbeath is scheduled for May 2022. In October 2021, the Flying Squad further developed the AI model for counting salmon at our hydro power stations. The SSE Renewables Hydro Environmental team monitor the annual salmon migration by counting salmon at 20 hydro stations and reporting this data to the local fishery boards. The Salmon AI proof of concept, built upon the existing architecture of the puffins model, and developed improvements to the centroid tracker, giving the ability to identify whether a salmon is swimming upstream or downstream. Salmon passing downstream would not be included in the count submitted to the fishery boards. These video clips are just some examples of the model in action. The AI model achieved an average accuracy of 95% over 3 consecutive days, which is an improvement on the existing counting method. The next step for Salmon AI is to perform live trials at 4 sites spanning the whole of the 2022 breeding period. In February 2022, the flying squad completed a 4-week proof of concept study at the Deep in Hull, with the objective of developing more advanced AI capabilities for identifying species in a subsea environment with low visibility conditions. The focus was on the use of sonar and LiDAR technologies, which generate 3D point cloud data and can be combined with audio from hydrophones to positively identify and track species underwater. Cameras were also installed in the tanks to act as a means of validation and to allow us to further develop our image recognition capability on the video. This video is from the North Seas tank and is the first time we have been able to use image recognition to detect multiple different species within the same frame. This particular tank contains species native to the North Sea. In the sonar clip on the left, you can clearly see the 2 sharks in the top of the image, which is mirrored in the video footage on the right. Also notice the ray that comes into shot from right to left in both views. The LiDAR sensor has provided very rich, detailed scans that will prove extremely valuable in monitoring benthic habitats and artificial reef structures. With more time for research and development, SSE Renewables are confident we can utilise this technology for gathering an unprecedented amount of data on the ecosystems local to our offshore wind farms. Our AI journey has taken us from what was first perceived as a crazy idea to monitor puffins, through live trials on a remote island in the North Sea, deploying cameras underwater at dams to monitor salmon, to having the capability to deploy an array of sensors underwater, mapping the environment and identifying and tracking the species within. We currently do not know what the next stage in our AI journey is. All we know is the voyage has begun and we are excited for our next adventure. Thanks for watching.
That week that we spent at the Deep in, I don't know if anyone's ever been there, it's the aquarium in Hull, was just an amazing week working with the staff there, putting all kinds of different technologies into the water and just seeing what would happen. Yeah, we just came up with some really good results. And what we did is the infrastructure that we put in there to support all those sensors. So we had to put a separate, local area network in, power, all these little cabinets which we screwed to the walls to make little workstations so the various manufacturers could put their kit in. And the hydrophones, we gifted all of that to the Deep when we left. So none of it was ripped out and taken away. It was all left there for further research and other scientists to use. So that's it. That kind of completes my presentation. Any questions? Hopefully one or two.
How do you stop theft and vandalism with those cameras on the cliff top?
In Dunbeef, it's just a million miles from anywhere. There's also a chap called Malcolm who lives in a house which is probably about 15 or 20 metres away from there that kind of looks out for us. All those, the cabinets are all locked and the cameras are anti-vandal cameras, so they're all security bolts and bolted down pretty, yeah.
Problems with the mains power supplies, couldn't SSE have helped you with that?
With the what, sorry?
The power supply to the...
Well, do you know what is crazy? So talking about power supply, obviously places like Dunbeef, Isle of May is on a generator solar panel, which is, of course, all smoothed out through the batteries, right? Dunbeef is coming from a domestic dwelling where you get power that's come off the grid, gone through a substation, is smoothed out quite nicely by the time it gets to the farm. The biggest issues that we had were on the hydro station sites, because we were working at a power station Well, the power that comes out locally from a power station is the worst type of power you could possibly have. There's a lot of EMF, back EMF on it, a lot of spikes, surges, there's valves, pumps, all kinds of things introducing noise onto the system. We have massive problems with it, to the point where in the end we got an electrical engineering company which we later on bought because they were we were their biggest supplier, and we just decided to buy the company. Worked on putting our own isolated power supplies in with a huge amount of surge protection and smoothing from using some products called MInstSCVEx. Don't know if anyone's ever heard of that. I would highly recommend their kit for anywhere where you've got problems with mains. But yeah, it's really ironic. You know, SSE, who's a big power company that's providing electric, we had to go and put our own isolated power supplies in to run the equipment. Crazy.
So how much time is spent in actually training the AI?
So the project works like this. So we are responsible for designing and building all the capture equipment and sensors, etc., for capturing the data. We're responsible for storing the data locally so that there's a backup of it, and then we're responsible for transferring it into the cloud via either 4G, landline, or fibre or satellite. Currently, that's where our job stops. Then it goes across to a Microsoft-owned company called Avanade, and Avanade have a team of data technicians that then process the data. We think it's a very inefficient way to do it, because the amount that SSE are spending on data costs and the problems that we get sometimes in transferring those big video files, even though that we've reduced them down into hourly chunks. So we're currently running our own R&D to work with something called edge processing. So rather than sending all the data up into the cloud, all the data is processed in the cabinet, or actually in the camera. And then the only data we have to send back to SSE are basically the analytics, which are just numbers, which are just a few kilobytes. Much more efficient way of doing it.
Hi, Jason. Yeah, just thinking about like offshore oil platforms where they've got like PAVA systems for like, you know, emergency evacuation, that sort of thing. Have you thought about like the sort of material technology that goes into those transducers for those specific harsh marine applications? Maybe taking a leaf out of their book, so to speak, and applying some of that to your materials concerns you have on your projects with, like, you know, saltwater corrosion, that sort of thing.
Yeah. We're working with a company based down in Southampton called I think they're called ISCVEx. So basically, they build a lot of the buoys that go out, and they did the global saltwater monitoring exercise, putting buoys out everywhere. So they've got like a lot of experience in kind of marine electronics engineering, and we drew on a lot of their experience when we were down at the deep. So yeah, it's a really good idea. You know, why reinvent the wheel? There are companies out there that have these specialisms, and I think one great thing about Excite is that we can take all these different specialists in and build these nice big project teams that do great things. So yeah, good idea.
Just on that, did you put that team together yourself, Jason, the subcontractor? So did you actually Google these things?
Yeah. Pulled the whole team together myself and had a lot of fun doing it. We had one or two people that came and went that kind of didn't fit in with the team. But I think, just having that skill in our business for being able to create these teams where we can, as my fellow director Alex always says, kind of punch above our weight a little bit, has really opened some doors for us. Yeah.
Okay, everybody. Any more questions for for Jason, or are we pretty much there? Okay, so big round of applause, please, for Jason and the Puffins. Could be a band. So yeah, thanks very much. So we will see everybody at the in the tent at 7. I imagine there will be some people perhaps potentially in the hotel bar between now and 7, and I look forward to seeing you all a bit later. Thanks again, Jason. Thanks for the sound. See you later. Cheers.